So today we're going to talk about the resource system in ARCs. I think, at least from my experience in the video game development, this is a bit atypical. It actually agglomerates a bunch of concepts that I gathered over the last couple of decades from different games and different engines. And I try to put them together and simplify them. The resource system actually is about a decade old now inside ARCs. I believe I wrote it around 2011, 2012, if I'm not mistaken. And I also realized that I never really explained all the details, but I often reference to it and what we can be done with it. But today I would like to try to give a more in-depth tour of it. So that's what we're going to do. If you have any questions, please feel free to interrupt me at any time, because I might just gloss over some details because I'm just too used to them. So what we're going to do first is start a new project. And as you can see, we have a bunch of extensions in ARCs, and there's a couple of them that actually add new resource type to ARCs. And so we're going to try to maybe demo one or two and to show how we can add our own types as well. And I will come back to the notion of type. So we're going to create a resource demo project. We're going to use a bundle and maybe remote as well. And I think that should do it. Good. So let's open this now. And resource demo, up, Visual Studio, there you go. And we're going to just build, debug, and release. We're not going to make much changes in code as usual, and but we might actually do one just to showcase something. So first of all, let's make sure that you can see it on the stream by editing the config. So we don't want this. We want to make sure that actually, let me zoom here too. Let's go to 200%. Should be good enough. Let's make sure that it's going to be right size for the stream and that it's on the correct monitor so that you can see it. And okay, there we go. So the bug, I'm not sure why this is so slow. Let's try this again. Okay, I wonder why this is so slow. Today, okay, even my Visual Studio is not very responsive. Let me check, just make sure I have nothing running in the background there. Doesn't seem so. This is annoying. I'm not sure why. Everything is slow on my computer right now, but it's not a good time to restart. I have a Windows update pending. That actually might be the issue here. Okay, well, we will have to do with a few seconds of delay every time I start ARCs. It's not ideal, but hopefully that won't be too annoying. The last thing we want to do is for the console to be readable, because we're going to use it a bit. So console font scale, I believe 3 was a good size. And let's try this again. Yeah, my PC is so slow today. Okay, yes, this is readable. Okay, so we are not going to keep our object, we're just going to keep the sound, just to make sure that my headset doesn't turn off like a couple of sessions ago. And we're just going to make it very low so that it doesn't bother us every time we start. Now, we are going to talk about the resources. In the settings template, there is resources. And as you can see, The section is composed of a few keys. There is one specific key that's called watch list that we will see a bit later. And there are three called config, sound, and texture. So in the resource system, we have three concepts. We have the concept of type, the concept of group, and the concept of storage. So how it works is that we organize resources in like a logical, we bundle them in a logical way. So like we're going to put all the texture together, all the sound together, and all the config files together. Those are called groups. And there are no limitation to how many groups you can have. It's just that Orcs is only using 3 groups at the moment. And those groups are config, sound, and texture. There is nothing special about them besides the fact that Orcs is going to use them. So, as you can see it, this is a group that we use as a key. So it's just a way to organize resources in a logical way. For each group, we have a bunch of storages. Storages are like they are places where we can find the resources. So you can think of them as like the drawers in your furniture where you would store your stuff. And the way the way storages work is that we define them in a list, and this list is actually a priority list, meaning that the first storage on this list is going to be the first one we're going to look into for that specific group. So for the config, that will be this is the first one, then the second, so on and so forth. As you can see here, it says Orcs will look for resources following the order defined by this list from first to last. And that's the case for any group. So if we look back at the resource demo, you can see that we have 2 groups defined here, texture and sound. And you can see that we have like 3 different storages by default. We have one called bundle colon, one that looks like a relative path, which is period, data, texture, and one that looks like an actual URL. And these 2, so the bundle one and the URL, are here because I asked for the 2 extensions. One is called bundle, the other one is called remote. And those are ways to extend how Orcs can fetch resources. And the way Orcs can fetch resources is through types. And I will come back to this very soon. So right now, we've seen that we have groups. So we have texture and sound, but as you can see, there's no config group here. And the reason for that is that when you start a new project, I'd like to not have the config file next to the executable. The only way for Orcs to find resources is by looking through storages. However, if you're going to define storages in config, you have a bit of a catch-22 there. It's like, in order to find the config file that will define the group for the config, you need to know where it is. So a few years ago, the only way to do that was to have the config file next to the executable, because Orcs includes the default storage, which is dot, which means local path for file type. And that's how we would find the config file. But it's not very handy. Like if you want to ship your game by using like all your asset package inside one, and that you'll see that there are 2 extensions that allow to do this. One is the archive one that I did not use today, which allows you to put everything inside a zip file. And the second one is the bundle one, which is, we're going to come back a bit later, but allows you to actually compile your assets, your resources directly inside the executable. You would not be able to find that config file. So the way we do that is that actually in code, if we go at the beginning, we see that before executing Orcs, we call Orcs config set bootstrap. And here we register a bootstrap function that's going to be called when the config module is going to initialize. So when the config module is going to initialize, your code from that bootstrap method is going to, bootstrap function is going to be called. And in this, you can actually like add storages for the config, or you can actually even load files if you want. And you can see here that the bootstrap function is here. And you see in the bootstrap function, we're actually initializing our 2 extensions, the bundle extension and the remote extension. And finally, we're adding storages. And so if we look at the resource group, you see it's just a config, the same thing that we've seen in the settings template.ini. And then we add a bunch of paths, and you can see that the one we've seen for like texture and sound, so like period data config. And we see that we also have the HTTP localhost config, and this one is actually bundle colon, like exactly like for the other one. So instead of adding them through data, we're actually adding the storages here programmatically, so that when the config module is going to be initialized and it's going to look for the main config file, it will have a few storages to look into and be able to find the resources. And you can see that at the end there's a boolean saying at first. It's just so that you can actually build your priority list. You can add at the beginning of the list or at the end of the list, and that allows you to give priorities. So because of the order of these calls, we are going to have the same thing as in the config file for the resource and the sound and groups. We're going to have bundle first, then data config, then the remote one. So the way this works is this is going to be called before loading the main config file, and depending on what we return here, Orcs is going to actually load the main config file, or it will, if you return Orcs stage failure, it's up to you to load any config at all. By default, Orcs will just run and not load anything for you. So going back to the resources, the way it works is that we've seen now groups and storages, but we have not seen types. The types is actually how a resource is going to be accessed. And it's basically a bunch of function that tells Arcs how to be able to locate a resource, or to open it, to read it, potentially write it, to close it, to move inside it. So it's a bunch of function pointers that we send to Orcs. We register them under a type. And by default, Orcs has a type called file. And actually, let me try to open Sublime. We're going to do this here. And can I find, sorry, just need to find the file. And register. Maybe in file. Oh, wait. I'm just going to look for it. Sorry. You don't see what I'm doing, but I'm going to move the window as soon as I find it. Resource. And it should be this file here, which Sublime is not helping me. Okay, it's okay. I'm going to open it manually in Visual Studio. Resource, that should be this guy here. There we go. Okay, if I'm looking for register type, there we go. So here we can see that we register a type at when we initialize the resource system, and this type is the file type. It allows us to handle file, and file as in file system. So you can be able to read local file or any shared folder on Windows, or anything that logical file operation can handle will be available to Orcs. But there is nothing special about this call. It's just Orcs makes it for you. So it registers a bunch of functions, and you can see that we have to give like a few information. And we're going to look at the .h file as well, so that we can actually have more info. And that should be this guy here. So when we when we register a new type, we are going to give it a tag, and the tag is just for the identification. So it's unique and it's mandatory. And we need to register a locate function. Locate function is just going to take a few parameters. We can actually see them above here. And it's going to take like a storage and name. So the way it's working, I will come back a bit later, but basically this locate function is in charge of telling Orcs if this specific resource can be found in this specific storage for this specific type. And then if you locate a resource, you send back a string, and it's like a URI. It's really like a locator, and this string needs to be able to be processed later by your open function. That's what you're going to pass to the open. So open is mandatory, close is mandatory. It's just like opening a resource, closing a resource. Then you have to do the get size resource, which is also mandatory. And then you have regular like operation on the file. So like seek to actually move inside the file. So you can seek from the beginning, from the end, for the current position. And you can also tell, which gives the offset inside the current resources from the beginning of it. Then you have two functions. One is for reading and one is for writing. The reading one is mandatory. You need to always be able to read a resource. However, the write one is optional. It's only if your type is going to support writing to a resource. And for the file, it's actually the case. So that's why if we go back here, you can see that we did register a file write. But you might like have your own type, or actually there is a second type that is registered by Orcs only on Android, which is for reading from an APK file, so an Android package, and there is no write support. So it's just going to, when calling the register, just going to pass null for the write function, meaning that there is no write support, and the fact that you have no callback for the write pointer will tell Orcs that there is no write support, and it will know that no, I cannot write to a resource. And then the same thing for delete. It's optional. It's only if you want to be able to delete resources or not. So the file type implements deletion, but your custom type might not. And the last one that's optional is the get time. And the get time is optional, and it's only used for hot loading support. It's just going to send the modified timestamp of your resource, and when you're in development mode, in debug mode usually, if you're going to use what we saw earlier here, which is called the watch list. If you're going to use the watch list, it means that you want orgs to watch for specific groups of resources. And you can see that you can give any name, like the groups we have here, like config sound texture. If you put it in the watch list, Orcs is going to monitor all the resources that you've loaded in the past, and if their timestamp change through the call to the get time function, well, Orcs know that the resources has changed and is going to load it asynchronously and notify all the system with an event so that they can be updated at real time. And we're going to showcase that a bit later. But yes, this is how you add new types. And so we've seen that the default type is called file. And if we looked at the Android, Orcs Android, we'll see that we also register one for the APK file. Actually, I might be able to find it. Orcs and native. There we go. So if I open this here, and if I look for register type, yeah, you see that we register one for the APK. And you can see that we do not give a write or a delete function, and actually it's not set as net, but there's no get time either. I mean that we don't support writing or deleting from an APK file, which makes sense because it's unmodifiable on the phone. And we're not, because it's not modifiable, there's no hot loading support, so we are not giving the get time either. But this is how we register new type. And you'll see those functions are actually quite straightforward. In the case of locate for the file system, we're just going to see if we can actually build a path based on the storage where we append the name of the resources. And if this path actually point to a file, well, we say that yes, we found it, and we're going to send back the path. Otherwise, we said no, it doesn't work. Same thing, the opening file is very straightforward. We just call the file open, file close, same thing, and so on and so forth. So adding a new type is not that complex, and we're going to see that even with custom types like support for the resources through web, or support like for zip file, or support like with the bundle, which are binary in memory, those functions are actually quite easy to write, and that allows us to extend the Orcs resource system almost as much as we want and be able to find resources from any type. We could even generate resources on the fly, like procedurally generated resources. It's very handy, and it allows us for the user to be completely seamless and transparent. The user only has to worry about the name of resource and not where it comes from. And this is handled by Orcs itself and the resource system. So if we go back to this now, we've seen all the three concepts, which are groups, storage, and types. So let's see exactly how this works. So when you're going to, actually we can demo it a bit. Oh, before that, actually, before demoing a bit, my goodness, my computer is so slow today. I'm so sorry. And we're going to copy a few resources for us to work with. So I prepared a few resources here. So we're going to go to the resource demo, data, texture. We're only going to play with texture today because it's both visual and it's the same thing for any kind of resources anyway. So I have a high res, hero, idle, and you can see that I have a bunch of frame. And let's see if it actually works. So we don't need this anymore. We are going to go back to our config file, and here we are just going to add one at the end, which is going to be data, texture, high res, I believe. Data, texture, high res, hero, idle. Hero, idle. Okay, and we're going to create a hero guide. So it's going to have pivot equals center, because I believe the sprite is huge. That's nothing, just going to remove this. So pivot equals center, and animation set ourselves. We have a key duration, I believe it's for 30 Hz, so we're going to put 0.33, and we have start anim, we're just going to use an anim which is idle, and the idle is coming from multiple files, so we're going to take the name of it and remove the digits, and it's a PNG, and also we have 4 digits on this one. So if you remember in the last live event we were talking about the animations, we could specify the number of digits. That's what we're going to do here, because they all have like 4 digits. So you can see 001 until 0001 until 0015. So we have the digits here, duration, start anim, idle, digits. I hope I didn't forget anything. So let's create it by hand first. Oh God, I'm not sure what's going on with my computer. Sorry about that. Object, create, hero. Okay, that's not good. Let's go in debug. Did I forget something? Very likely. It's always a live effect. Object, create, hero. Yeah, something is going on. And I don't have any message. What is going on here? Let me double check again if I can find any weird behavior, any weird thing running on my machine. Because the config I'm pretty sure is correct. So the rule one idle. You know what? We're going to try to locate the resource first. But there is something rather wrong going on here. Why is this taking so long? I definitely should have updated and restarted my
Someone
computer.
suggested that they think it tries to load resource from localhost, which is offline.
That would be past. Oh yeah, actually, you mean the timeout for localhost? Yes, actually, you're totally right. So that's why I should probably put this here. Thank you very much for that suggestion. But the whole thing is very slow. Like starting arcs take like seconds instead of being instant. And everything, even when I popped Sublime Text, it took me like 10 seconds to start it. But you're totally right. That was the issue. There's a timeout for the resource one. My bad. Sorry about that. And thank you for the suggestion. But here it's timing out too. You know what? We're just going to remove the path entirely right now. Why is it so slow? Okay. No, there's something else going on apparently. Oh, it's still trying to connect with remote. Okay, you know what? We are not going. Oh, it means that it doesn't find it locally. So I guess I made a mistake on the path. But okay, fair enough. So I'm not going to use remote for now until I sort out my local setup. So if I'm trying to create my hero, okay, it's here. Anyway, let's put the remote on the side and I will spin a web server later after. I'm not exactly sure. Know that the remote extension is meant like as a proof of concept, not something to use in production, and same for the archive one. The bundle is meant to be used in production, but it's still work in progress. So we will see an example on an existing project where I know it's working later. So our hero is working, and that means that when we try to locate the texture, and we're going to try to locate the texture with its name. So let's just copy the name because I don't want to have to type it. There we go. If we're going to locate this, it tells us it's file. So the file is the tag for the file type of resources. And then it's the path where you can find it. And this is the location entirely. It's like the URI. It's file colon and where to find the resource. Once you've located a resource, it's going to be cached in Arcs so that you're not going to have to do a bunch of requests actually. So I have to go back. How does this work? So when you request a resource, we requested a resource from the texture group, and we requested it with this name here, sword01 idle 0001 png. So when we request a texture, we are going to go through all the storages in order, and Orcs is going to poke all the different types that have been recorded in order to find them. And you're right, and that's why probably we are timeouting because my web server is not running at the moment. So the way it's going to work is that it's going to ask the file type with the storage called bundle colon and with the resource called sword hero idle 001. And file says, no, I don't know how to make sense of this. I don't know how to find the resource. I'll just say, okay, next type. Next type is going to be bundle. It's going to ask bundle, do you know how to find the resources in the storage bundle with the name idle01 bundle? We say, nope, I don't know about that. Next. And that's where we were probably asking the remote one to say, can you tell me if you can find it? And because my web server is not running, there was probably a timeout. And thank you so much for the suggestion. I think the timeout is something like 60 seconds. We would have waited a long time. So if all the types have not found it in the first storage, we're going to move on the second storage. And this time we're going to ask file, can you tell me if you can find a resource that is in the storage data texture with the name idle01? And this time file says, yes, I actually found this. No, actually I didn't find in data texture, it says no. So we're going to go through all the types that say no. And when we reach this storage here, this time files will say, yes, I know how to find it. And here is the path. And then this location has been written by Orcs. And it's going to be set in a cache. Orcs will not make requested for that specific resource ever during the runtime. It knows which type can handle it and in which storage it's found, and it's going to be cached so that any later request is not going to ask all the different types for all the different storage. We know where it is located and we're going to keep it in cache. And this is important for, of course, performances, but also because it's going to be used for the watch list. Remember the hot loading? We're actually just going through the cache to know which resources have been asked, and so that we can hot load them. And it's also going to be used if we need to resync the resource storages, and we will come back to that later. It's a way to swap entire assets, entire resources at the runtime. But we'll come back to this. So basically, that's the gist of it. That's how it works. That's how Arcs is going to ask a bunch of types if they can combine the storage and the resource and find them. And as soon as the type says yes, we're going to keep this location and reuse it in the future. And there, if we look at the resource, we can see that there's a clear path, clear cache, function. And if I do this, Aux will forget all the cache for all the groups. But actually, this function, you can actually specifically say, I want to clear the group for just the texture. And we're going to showcase how this works later. So right now we are seeing the basic of this. Let's make another example. We're just going to copy this texture. We're going to call it test.png. Okay. And this text.png, we're going to put it also in texture here. And this one here, we're going to we're going to modify it just to make it obvious. We're just going to make, oh no, we're just going to negative it. There we go, saved. So this one here is a negative version, and the one in the high-res version here is the regular one. And that's how we can tell them apart. So now if we go back here and we ask Aux, actually now Aux starts faster. What's going on with my computer? Anyway, okay, building. Yeah, now it's instant. I'm not sure what's going on. I'm so sorry. If we're going to locate in the texture test.png, you'll see that it actually finds the one data texture, and that's normal because data texture is first in the list of storage for the group texture. So if we were to actually, let's create a test object as well. So test pivot equals center. We're going to use ourselves as a graphic, and the texture is going to be test.png. And let's just start this and create test. You can see that we found the one texture, which is a negative version. And okay, fair enough. Let's say now if we look at the resources, you can see that we can also add and remove storages. And let's see what remove storage step. We can actually remove storage from every storages for all the groups, or for a specific group, or inside a specific group we can remove the storage with a specific name. Right now what I'm going to do is remove all the storages for texture. So there is no more storage defined for texture. So right now if I'm trying to locate anything for texture, it only knows the one that is hard-coded in Aux, which is period, which is in the local folder. So let's ask if we can actually locate inside texture test.png, and it says no, I cannot locate it anymore because I don't know where to find it. We removed it from the list of potential storages. This can be helpful at runtime when you want to swap, like for example, let's say between high resolution assets and low resolution assets. And let's see how it works. So we're just going to have it automatically created for us so that we don't have to do it at runtime. We're going to create our hero here. Okay, so we have the hero, and this one is the high resolution version of it. And actually, you know what? I think it looks even better if we put smoothing control. Let's see. Yeah. So this is the high-res version. If we were to remove the storage for texture, we could just remove the one we want, like the high-res one. Let's say that the user in the menu said, no, I want the low-res version of all the assets, of all the resources. And what you would do is you're just going to add a storage for the texture, and this time I'm going to copy paste because I'm not going to make the mistake by hand. We're going to ask not for the high res but for the low res one. Mean that now the storages have changed, but if we were trying to locate the file, it will still locate in the old one because of the cache. But now that we've changed the storages, we can tell Ox, okay, go through the cache, look at all the resources that we found in the past, and check if they are still in the same location. So this is called a sync. And if we look at the resources, we see that one is called sync. And we can sync like a specific group or sync all the groups. And it's just going to go through all the cache, check all the known resources that we've accessed so far, and it's going to check if they are still in the same storage or not. If they are in a different storage, it will send an event to Ox to tell it, okay, these resources has changed in somewhere else, reload it. So Ox will reload it. The resource is completely asynchronous. It's made on all the transactions are made on a separate thread. It's going to reload it, and it's going to notify all the system. So if I do this, normally, it should sync the low-res version of it. And you can see that automatically, at runtime, the low-res version have been selected, and those are the ones that are found inside low-res, euro, idle, and they are these images, the low-res one. So at runtime, without doing anything, by just changing your storages and calling it a sync, you can swap all the resources on the fly, including like the sound, the texture, the config, and whatnot. So if we do it again, if we now put back the high-res resources, we're not going to remove the low-res, we're just going to put the high-res in higher priority. So we're going to do add storages for texture, and we want the high-res, and we want them first. And this time, if I do a sync, we're back to the high-res one. This is very helpful if you want to handle like different kind of resources, like high definition, low definition, or if you want to theme your game, like you have like, I don't know, like a specific theme for Halloween. You can just load the Halloween one, or have the user select like a dark versus light, or whatever you want. And know that any resources that are not found in the new storage will just keep their old version. It means that you don't have to have all the resources in the new storages. You just need to have the one you want to modify. All the ones that are not modified will remain as is, as already loaded in the engine. So you can do like a partial overlays, is what I'm saying. So that's fine and dandy, but what if you need to handle something that is not a texture, not a sound, or not a config? Well, you can actually add your own custom groups, and this is as simple as just giving a name for your group and using that name in your code or when you locate through the console. And let's say, for example, I'm making a word game and I want my dictionary stored somewhere and being able to access them as any kind of resources, and I will call this group words. And I'm saying, okay, words are going to be stored in data and words, and that's the only place where I can find them. And this is a new custom group. All I had to do is just define it like this. And now if I'm actually going into here, going to data, we're going to create a words one, and we're going to create a new file, and we're going to call it a dictionary.txt. Okay, so if I were to ask, okay, I want to locate my dictionary text, but I'm going to locate it inside texture. And it says, nope, I don't know dictionary text in any of the storage defined for the group texture. However, now, oops, if I want to locate it inside words, it says, yeah, I know where it is. So you can add your own type of resources for whichever purposes you want. And you can use the same centralized API to access them. So like resource locate, resource open, resource read, resource write. All this allows you to access any resources that have been defined in any storage for any types in any groups. So I think this is very flexible and very powerful. And if we look at Arcs resource, I believe I open here, the API, you see that you have all the functions you would expect from regular file API. So there's a locate one. Locate, you can just pass a group and a name. And if it is not found, it's going to say, if it doesn't exist, it's going to say, okay, I cannot find it. I'm returning Ox now. but you have a located storage, and this is if you want to create something like a configuration file or like a save game that does not exist, you can tell it in which storage in particular you want to create it. So you're going to call it located storage, and you're going to provide the storage this time. So you're going to say, for example, I want to let's say I'm saving my save file as a config file. I want to locate in storage group equals config, storage wherever I want to save it, and the name, I don't know, save.ini. And Orcs is going to ask all the type if one is capable to access the specific storage and is able to write to it. And because if it doesn't exist, it needs to be able to be created and written. And that's how you can create like save file. Actually, when you actually do the config.save, that's what is going to happen behind the scene. You can find the time, the type, you can open a resource, you can close a resource, size, location, seek tail, but the most important for you is probably the read and write. So if the write is not implemented by the type that has been used to access these resources, it's just going to return, I believe, 0. Yeah, nothing could be written. It's going to return 0. And if you're going to read, you see that there is a callback parameter. If you do not pass a callback, if you put orcs null here, this is going to be a synchronous call. It's going to block the thread calling orcs resource read. And maybe it's something you want. I don't know. You might have your reasons. But if you want asynchronous resource read, no matter the type where it is, like if it's from, I don't know, like from a zip file, from doesn't matter. This is going to happen on a separate thread, and once the resources have been, once the amount of data has been that you requested has been read, your callback is being called and will inform you that the data is ready and available to you, no matter where it comes from, no matter from which storage. All this is completely abstracted. So by just defining if you want to call back or not, it's going to be a synchronous or an asynchronous call, and that's all you have to do to deal with resources. You don't need to know if it's a file, if it's coming from memory, if it's coming from a zip file, if it's coming from the web or anything. You don't need to do any of this. Okay, so custom resources, custom groups, sorry, are very easy to handle, as you can see. You just need to have a label that you use on both sides, and the labels can be anything. They just need to be unique. Let's talk a bit. We talked already about the sync, so like how to swap entire group of resources at runtime. Let's talk a bit about the watch list, which is the hot reload, which is very handy in debug or development build. And here, if you see that if we go to our debug one, we have the watch list that's defined. Let's actually define it also for release, so that we can just use our release build as if it was a development build. Here we're going to say, I want you to watch for all those groups, config, texture, sound, and if you see that something has already been loaded, and again, we're going to use the cache to know what has been loaded. If something has been loaded and is in the cache, if it's a timestamp has changed, and if the type that has loaded this resource has provide the getTime function, then we're going to reload the data in the background, and we're going to send an event, broadcast an event that all the system can pick up and like modify that thing. So Orcs will swap on the fly the textures and sounds and the config as well. And you know that, for example, things like shaders will be recompiled on the fly, like graphics will be changed. Let's actually show it with graphics right now. So if we start this application here with the animation there, let's put it a bit like this. Let's open its data, texture, iris, hero, idle. Let's modify the first frame. So open with pen.net. Okay. And let's bring pen.net here. There. So can I zoom? Yes. I'm going to let my inner artist work. Okay, I modified this frame, and as soon as I'm going to save it on disk, you can see that Arcs has reloaded that specific frame right away. It's because the timestamp on disk has changed. The watch list is going to monitor all this in parallel and is going to check all the timestamp. And if a timestamp has changed for a specific resource, that resource is going to be reloaded. Once this resource has been reloaded asynchronously, it's going to send an event to all the systems so that they can process it if they want it. And in this case, it's a texture, and the graphic system is just going to process it. Let's save it back, and you see that instantly it's been picked up. And it works with anything, any resources, like your own type of resources, like for example the dictionary. If you change your dictionary on the file for your word game, it will send you an event and say, oh, the new dictionary is available. The resources has been either modified, added, or removed, and whatever you do, whatever you want with it. And it's exactly the same system used by Arcs internally. So if you were to use it on the user side, it would be the exact same system that is used at the engine level as well. So now let's put it back. So that's basically auto reloading. This is very useful, like for when you work with an artist. And that's actually where the remote extension is handy, is because you can have all your resources like on a web server that is running on the like artist machine, for example, and you can run the game on your own machine, and it's going to pick all the resources remotely on the artist, even when they modify it. So when you run, you will see at runtime the changes on your machine. That's a way to collaborate like over distances. Um, Maybe we can give it a try. I did not like prepare this part of the demo, so let's maybe do it at the end, because maybe I will make a lot of mistakes and it's not going to work. But that's the idea. You can see that hot reload is working fine. I'm just going to keep this open just in case. Next on our agenda is like patching. The fact that we're using priorities for the different storage allow us to do easy patching. Like, because we know that for each resources we're going to first check in the orders of the definition of storage, we can actually like modify just like assets and put them in a higher priority storage, and those are going to be picked up first. So it's very handy because you can just add like when you release a new version of your game, you just have to modify the config, and you just have to make sure the config, or you can do it in code if you want to. You just add like data patch, and this is going to be this is going to be checked first when you're going to look for a texture. So like for example, remember the test texture we had here? Let's say we want to patch this, but we only want to patch that texture. So the one that is in texture here, we're going to edit again, and we are going to, I don't know, can I, something that's, no, like maybe image, color depth, not sure why it pops on the other screen. Let's put in grayscale, okay, and change color depth a little bit, okay. And I'm going to save as, no, you know what, cancel, I'm just going to save it like this. And is it this one? Yeah, okay, this one. So if I remove this one, let's remove it entirely and just put it in a place where it's not going to be found. If I'm going to, okay, I have this guy, and if I'm going to, the test is going to be on top of it. Yeah, let's just move them a bit so that we can see test is just going to be a bit on the right, while our hero is going to be a bit on the left. Okay, so this is our regular test. That's the image we have in the texture, high-res, hero, idle test. We're going to put it at the texture level, yeah, and it's still going to work. And now if we're going to actually patch, so where do we put the patch one? I already forgot. Okay, data patch. Here, if we're going to create a patch version, and we're going to put our test inside the patch, yeah. now it should take the patch version. Let's see. Nope, I missed it. What did I miss? Patch. If I knew how to type, that would work better. And you can see, yeah, I removed the background apparently. And you can see that now it's going to pick up the patch version of this specific resource, even though the original one is still inside texture. And this way you can just, every time you add a new patch, well, let's say that this was patch 1, you can add like new folders and put them in front of the other one with a higher priority, and you just can do like layers of patches. So here right now I did it with like file patch, but it could be like any kind of resources. You put them higher in the priority, and you can even add them on the fly with add remote storage function or command, and you can just make sure that some paths, some storages, sorry, have been checked first, and that's where you're going to add the new version of your file without having to modify the old one. So you just have to ship the patch folder or the patch archive or whatever you want, and just make sure that you modify where to look in the storage. And you can actually like have your config file there as well. So if when shipping the game you already define the patch 1, you know that the next time patch 1, the patch 1 is always been checked, and next time you just have to put your main config file, the override, inside that patch 1, and it's going to be picked first, and you can just change that, and the patch 1 you release it with a path with patch 2 already inside it, and so on and so forth. So this is very handy. This is the overlay of different storage is very handy. So now let's actually see the bundle extension. So if we look at the bundle extension, the way it works, and this time I'm going to use a little project I did with CreamPuff like very recently for the Ludum Dare 51. Okay. And we made a little game called Cybermenace. And of course, it's on the wrong window, so I'm just going to modify data, come on, data resource. No, that's not it. So that's wait, where did I do? 51. Oh, data config has been. There we go. Not sure what's going on here. Oh, did I erase stuff? Oh my goodness, let me. Sorry, was working last night. What did I do? ID 51. Did I erase a bunch of things? No. No, I could not find file. Oh, it's because I renamed them. I forgot to regenerate the solution, but now it's called Cybermenace, of course. It's called Cybermenace. Okay, and in display we're just going to put monitor 2. So let's see. Okay, good. So that's a little game we made with CreamPuff for the Ludum Dare, and you see there's a bunch of sounds and music and animation and texture and config and so on and so forth. And right now this is running from directly from multiple files on the file system. Like if I do, actually I'm not going to see anything here. So render font console font scale 3. Okay, if I'm doing locate texture, I believe one is called player wire.png. Yes, you can see it find it as a file in data texture player wire.png, and that's actually our little blue guy up there. Right now it's finding it from the file system, but we are using something called the bundle extension. It's a it's an extension that's worked in progress, so it's not like fully ready for production. Because there's a few more features I want to add to it. Right now, what it can do is that it can pass all your config data and find all the resources that are expressed in config and make sure that those are going to be uh, packaged inside in memory with the executable. And to do that, it's just going to generate a bunch of arrays in C and build a table with all the names and put them and make sure that it's built with your executable. And this way, when you look for the resources, it's just going to find them directly in memory. So it works well if you don't have like hundreds of megabytes of data. If you only have a few megabytes of data, it works well. But if you have like bigger projects, it's not the way to go. That's why you want to have those bundles be separate from the executable later, that as an option, and also add compression. Right now, it's not supported. It's the kind of thing I want to add later. But if we're looking at the include, you can see that there's oxbundle.h, and that's where we define all the type, the new type. So if we don't look at the process is how we are going to go through the config and find all the resources and then collect them and then like encode them into a C array. So this is not relevant to the actual type. However, what is relevant to the actual type are the functions. You can see that the bundle locate function is not that long. It's just a few lines, and basically just going to take check the storage. If the storage is the one that's called bundle colon, then it's going to check. It's going to take the hash of the resource name, and if you find this in the hash table where we keep all the matching data and their name, is going to just send the index inside that table, and that's going to be the location for it. And for opening, it's very simple. All it's going to do is going to check that he understands the format that has been passed, and it's going to allocate a structure that is basically just a cursor in it, so that we know where we're reading at, and it's just going to store a pointer to the data in memory, and you can see that the index is coming from the location that we received. And we're just setting the cursor at 0. Closing is just freeing that memory, that structure that we created. Getting size, we have it in our data. Seeking is just moving the cursor, so it's also a very short function. Depending if you want to start from the current on the end, it's very simple arithmetic. Telling is just sending the cursor, and reading is basically a memory copy. You copy from memory into the destination buffer, and that's it. And we do not support writing, deleting, or outloading because things cannot be modified at runtime. So that's how we defined a new type of resources, and we register it at the beginning of our application, and that's it. Now Arcs knows how to find resources from memory. So if we're going to like start it, let's see. Quick example. This is still running. We don't need this. I want to. Can I? Can I explore? Nope. Okay, so I'm just going to open the command line, and we're just going to go into LD51, and we have our Cypress. I believe we have a debug run right now, and if I call it with .h, you can see that we have option that is the bundle. So actually, when you have the bundle extension, it will add a command line parameter, which is -b on the -bundle. And if we start it like this, -b, you can see that it's going to run the game, and it's actually going to try to find all the resources that are defined in config. And it tells you what it discovers, all the resources that have been discovered, and once you find all the resources and they have all been discovered, it's going to start bundling them and tells you what is the size of all the resources. So like for example, select.ini is 1.52 kilobytes. And then you can see that the music are slightly bigger. We have like one music here that's 1.3 megabytes and so on and so forth. And it's going to build all this into like C arrays in a file called orgbundledata.inc. And if we look here, we can see that we have to wait for Visual Studio to load the file. you can see that we have a file called org-bundle-data.inc that contains a bunch of C arrays, and those are the data we've seen, that the one that have been discovered and bundled. And you can see at the end we have a table that's been created with the name of the resource, the array, the actually array that contains the resource and its size. And now if we build this one, all the resources are going to be baked inside the executable. And if we run it, so actually the Cypermenace, you can see that now it's 7 megabytes. I didn't show earlier, but it was about, actually we can easily do it. All we have to do is delete this and build again. And yeah, originally it was 1.2 megabytes for the debug version, and now it's 7 megabytes with all the data in it. And actually, we can just regenerate it. There. And here, let Visual Studio reopen the file, and we can build it again. And now if we look at it, you can see it's 7 megabytes, and if we start it, the game looks exactly the same, so we don't see the difference. However, if we ask for locating the player.wire.png, oh, wait, what? That is not how it's supposed to happen. Is it the right name? Let's see, maybe I did not find the right name. Let's see. Data, texture, player. Oh, it's lowercase. Okay, everything is lowercase. That's why. The thing is that because we're doing like case sensitive inside the bundle, it did not find it in bundle. But on Windows, the file system is not case sensitive. That's why it's been found. But what we want actually is player.wire.png. And you can see that now it doesn't find it on the file system, but it finds it in the bundle with the index 13x, and basically it finds it from memory. And the way to verify that it's actually what's happening here is just going to LD51. Binary, you can see that our debug version, I could have done it with a release, but actually, you did not see. Yeah, the fact that I used the debug was mostly so that we could see the log of the bundling inside the command line, but we could have done it with a release one. So if I take the debug one and I just copy it with the org.dll, and I'm going to copy it like somewhere else, completely like dump, we're just going to put the exe and the org.dll, and now if I start it, you can see that it's still run exactly before. You have the music, the sound, everything is there. And you don't have any external file. Everything is inside the executable, and it's found in memory. Like, okay, I'm going to die. So resource, locate, texture, wire.png, and you can see that it's memory, and all the resources are coming from memory. So that's the bundle extension here. Okay, and because we are already, come on, because we are already at past the 1 hour mark, I believe. Yeah. I will probably not do the demonstration with the web server and the remote, but that's the same idea. It's just instead of picking the resources from memory, you would pick it from the web server and being able to hotload them at runtime and things like this. It's just that the remote extension, which is not in this project actually, in the other one, the remote extension here, it's basically finding also a bunch of function, but it's just going to do a HTTP request. And you can see that here we have get time, in that we have the support for hot loading, and get time is just going to issue a query of type time, and the type time for the query. It's just going to be a head, I believe, if I'm not mistaken. It's code I written a long time ago, and it's all by hand. So you can see that I actually craft the packet manually and I just send it through the sockets. Um, yeah, it's very simple and it works. And it's a proof of concept, of course, because it only works with HTTP and not HTTPS. It's not made for production, but it can be an interesting development tool, or actually the base of something to write. You can see that it's not a very long file, and it adds a new type of resources for ARCs to be found through a web server, and it works on all the OSs as well. And I believe that covers about everything. Do you have any questions?
See if somebody has a question or not.
Yes, I believe someone is typing. A large exe is not the preferred way because everything will be stored in memory. When your exe is going to start, everything will be in memory. So, like if your exe is like 500 megabytes, well, just starting it is going to allocate 500 megabytes of memory with your resources in their packed form. So, like it's going to be the PNG and not the actual texture that's going to be uploaded to the GPU. So it's nice for like small projects like game jams or like small games. But I would say if you go over a few dozen of megabytes or maybe 100 megabytes, over that, it's probably not a good idea. That's why I want to modify the bundle extension to optionally support having bundles outside. So still binary bundles, but not embedded inside the exe on the side. And I have multiple ones as well so that I can support like patching and overlays like we mentioned earlier, and also compression. I'm planning on using LZ4 for compression to make sure that this footprint would be much smaller, and also the memory footprint if you decide to put it there. So it is not the preferred way of distributing, but it's more of like a personal taste versus where you put the threshold between memory usage and convenience. Because it's definitely convenient. People cannot poke at your data. It's much harder to modify your assets when they're already in binary form inside your executable. It's doable, of course, but it's not as simple as just opening a file on disk and in your image editor or something like this. Are there any other questions? I will take that as a no then. Thank you everyone for being here. Sorry about the technical issues we had at the beginning. I'm not sure exactly what was going on with my computer. Hopefully that won't happen in the future. And wait, someone is typing. If it has been well, the bundle extension right now cannot, but I guess you could. You could like add checksums, for example. You can be more creative and you can find ways to track these kind of things. But again, it's always a race of how people can understand what you're doing versus what you're actually doing. If you everything runs on like the client machine, eventually they can be as clever as you and thwart any protection you have. If it has a component that requires like a remote connection, something like this, much harder. But again, is it worth the effort? Probably not, especially more games now support things like modding, and that would be against it. But it's really like a personal preference at this point. But right now, the bundle extension does not. However, you would have to be a bit creative if you want to modify it in place and understand how linker works, and especially if your data is going to be a different size, it's going to be much more annoying for people to actually rebuild and relink your executable with data that's been modified. But the bundle extension at the moment does not do any CRC check or any like attempt at checking if there's been modifications. Yeah, there's no tampering checks at all in the bundle extension. But again, the bundle extension right now is in a separate branch. It's not in the default branch. It's in the bundle branch, and it's still under development. I plan to add at least support for external bundles and for compression. Um, but I might add other features as well if it's interesting to people. Any other questions? Well, I think that concludes today's. Hopefully, that gives a better idea of how the resources work in Arcs and how flexible the system is. From a user standpoint, everything goes through the same interface. You don't have to worry where the resources come from. So, like if it's a file, if it's coming from memory, if it's coming from a remote server or anything, all you have to worry about is their name and where you can store them. And Orcs will do all the multiplexing of the storages, the groups, and the types for you behind the scene. And it allows things like swapping entire batch of assets batch of resources at runtime, like for low res versus high res, or versus having different themes, or like hot loading. Everything is made possible because everything goes through the same API and the same cache system. So that's the gist of it. Thank you all for attending, and I will see you next time. Have a good day.